Okay, welcome to this video, the last in our series on differential equations. This is on coupled first order differential equations. So coupled equations are where we have two equations in two variables. We've got x and y in our example, and both x and y are functions of t, functions of time. This is very common in modelling of real life situations. It says in the workbook predator-prey model, so where you've got a predator and a prey. If the predator eats too much of the prey, then it hasn't got enough to eat, so its numbers will start to reduce. But if there are fewer of the predators, then there'll be a lot more of the prey. So if the predators breed, they've got lots of food to eat, and that their numbers grow. So something like, for example, lions and antelopes, perhaps. So let's have a look at how this works. We'll go through this example. So here we've got two equations modeling the amounts of substances x and y. So the masses of x and y are the variables little x and little y, and we've got some international conditions. So part A says show that d2x by d2y by dt squared plus 3dy by dt plus 2y equals 0. Now that's giving us a clue how to start on this. We need to get a second order differential equation just in terms of y, so we're eliminating x. So we're going to take this second equation here and we're going to differentiate it with respect to t. So for A, start with dy by dt equals x minus 3y, and differentiate with respect to t. So on the left hand side, what we're going to get is d2y by dt squared. Let's move that up a little bit. That's an equal sign there. On the right hand side, differentiate x, we get dx by dt minus 3 dy by dt. So we've still got something involving x and y, but we know that dx by dt is equal to minus 2y, so we can substitute in there. So that's equal to minus 2y minus 3 dy by dt. And now all we've got to do is rearrange this all to one side. So we get d2y by dt squared plus 3 dy by dt plus 2y is equal to, see the equal sign because of that line, is equal to 0. So that's part A done. So let's go on to part B. Find an equation in terms of t for the mass of substance y. So really what that's saying is solve this differential equation. Oops. Okay. So for B, what we're going to do is solve the differential equation. So our auxiliary equation is going to be m squared plus 3m plus 2 equals 0. That factorizes to m plus 1 times m plus 2 equals 0. So m is equal to -1 or -2. So our general solution is going to be y is equal to a e to the minus t plus b e to the minus 2t. Now we've got some initial conditions for x and y. So we can substitute in to here so we can say at where are we? T equals 0. Y is equal to 0. If we substitute in e to the minus t is 0, e to the minus 2t is 0, so we get 0 is equal to a plus b. But we've now not got something else that we can substitute in here. So a couple of ways to do this. One is that we could differentiate and then use the dy by dt equals x minus 3y and substitute into that instead. Or the other thing that we can do is we can get an equation for x and substitute into that. So quite often what we do with questions like this is we really do B and C together, because C is hence find an equation for the mass of substance X. So let's do that. So let's take this, rearranged X. So X is equal to dy by dt plus 3y. So that's equal to, well, we've got to differentiate this. That's minus a e to the minus t minus 2b e to the minus 2t plus 3 times all of this. So plus 3a e to the minus t plus 3b e to the minus 2t. And if we simplify that, we get minus 1 plus 3 is 2, so 2a e to the minus t plus b e to the minus 2t. And now what we can do is we can substitute into here. T equals 0, x was 20, x equals 20, so 20 is equal to 2a plus b. And now we've got simultaneous equations that we can solve to find a and b. So if we just subtract this one from this one, we should be able to see that a is equal to 20 and b is equal to minus 20. Now we can go back to what we had here and also what we had here and write out our solutions. So we're going to say so y is equal to, which way around is it, 20 e to the minus t minus 20 e to the minus 2t. That's solution to part C. And for x, we've got x is equal to, well, we want 2a, so that's 40 e to the minus t. Again, we've got plus b e to the minus 2t, so that's also minus 20 e to the minus 2t. Yeah, and that's the solution to, oh, sorry, that's C, and that's B. There we go. So we've now answered part B and part C together. Then the last part of the question that we need to look at says, part D, show that there can never be an equal amount of substances X and y. So for D, what we've got to do is we've got to show why this can't equal this. And I think the best way to do this is to say x is equal to 20 e to the minus t plus 20 e to the minus t minus 20 e to the minus 2t. So I'm splitting up that 40 e to the minus t. We think of a bracket around that. That means x is equal to 20 e to the minus t plus y. And 20 e to the minus t must be greater than 0. It's greater than 0 for any value of t. Obviously, for large values of t, that's going to get very small, but it's never going to be 0. So x is greater than y for all t. So there. So x can't be equal to y, and there cannot be equal amounts or masses, I guess we could say, of x and y. Okay, so that's an example of solving coupled differential equations. If we just go back very quickly to the equations that we've solved, these were relatively simple ones. They've just got dx by dt, dy by dt, and x and y involved in them. If you've got another function here, you've got to remember when you differentiate to differentiate that as well, and it can make it a little bit more complicated. You may also find, so here the substitution was very simple here. We just substituted for dx by dt, but sometimes it's a little bit more fiddly, and may take two or three steps. Definitely something that needs practice. So there are questions in exercise 8D in the textbook for that. But that's the end of our example now, showing how coupled first order different simultaneous equations work, or coupled first order differential equations. Thanks for listening.